Hello everyone, today we will continue our talk speaking about limits and its properties. As we said at the last class that we can define the average rate of change, which is the slope of the secant line. For example, in this case we have the line which is PQ. So to define the rate of change of this function f, so we would say, let's take the slope of this secant line or of this line. So I would take the change of y's over the change of x's. So as if I'm saying, instead of writing the y's, I would write the fx. So take the point which is a random point x. So I would take a slightly change in this x, which is delta x. So I would say that the second point is x plus small change, which is in this case delta x, over x2 minus x1, which is the delta x, the changes within x's. And then we define the slope at this point as when this change goes to 0, or we have a small change, we would call this the limit. So to find the slope of the tangent, which is the blue line at this point, we would say this is the limit when dx goes to 0 to the same amount. So using this limit, we can define the slope at this point, which is the slope of the tangent line. While if we have a secant line like P and Q, this is the slope of this line, rate of change, which is the average rate of change. So again, as we said, when delta x goes to 0, so this amount or this expression will be approaching to a certain value. This value is the limit of the slope of the secant line, which is the rate of change of this single point, which is in this case P, and we call this instantaneous rate of change, which is at the same time is the slope of the tangent at this point, which is P. So this is why we can define the limit. We can have the limit with the slope of this line at this point. So guys, let's take the informal definition of the limit. So as we said, let's take this expression and let's see how we can define the limit with a function. So if we have the function fx and I'm writing the limit of this function x when x goes to c equals to L. So this means the limit itself, like the limit of this function itself when x goes to c, is a value of this function. So as if I'm saying if instead of x we have c, so the y value of this expression, which is the limit, equals L. So x goes to c, the function goes to L. This is why we have the limit of this function fx. So sometimes guys we have limit from the right and limit from the left. So this means if x becomes randomly close to a single number, which is L, so x approaches c from either side, from left or right, so the function or the limit of x approaches the L. So as x goes to c, the function or the value of the function or the limit of this function goes to L. Let's see an example how we can use this definition. Okay guys, before speaking about these examples, we have a note. When we said that if x goes to this limit L and when x goes to c, this doesn't mean that the value of fx when x equals c should be valid or should be exist. So the limit is different from the value of the function. Okay, sometimes they have the same value, like the limit and the value of the function x fx, but sometimes yes, we do have the limit which is different from the value of this function. That's why in this important note it says the existence or non-existence of fx at this c, x equals c, has no relation on the existence of the limit of fx when x goes to c. Even when we have like fc is not equal to L, which is the limit, we can say that we have the limit of this function. Example, let's take the simplest example, which is fx equals 2. This is a line, x equals 2, the red one, y equals 2, as if I'm saying y equals 2. But look at this point, which is the open circle in this case. So guys, in this case, this function is not defined and at x equals 1. So that's why it says x cannot be 1. This means this function has no value when x equals 1. That's why we draw this open circle. But let's take the limit of this function. So the limit of fx when x goes to 1 from the right or left, it's 2. Why it's 2? Because look at the point which is exactly next to this open circle. The value is 2. Look at the point on the left, exactly at the next to this open circle. It's 2. That's why we have the limit of this function, which is 2, but the value of fx is undefined. So in this case, we have the limit, but we don't have the value of the function fx. So fx equals open circuit or undefined at x equals 1, while the limit equals 2 when x equals to 1. Let's take another example. Look at this function. Fx is defined as follows: equals 2 when x is not 1, but for this x equals 1, we have fx equals 4. So this function is defined by two formula. When x equals 1, it's 4. When x is not 1, it's the line which is 2. So in this case, the limit of this fx is 2. Why it's 2? Because look at the point next to this open circle. The value is 2. And look at the point from the left. It's also 2. So in this case, the limit of fx equals 2, while the value of this function f1 is 4, because it's defined as 4. So guys, in this case, we have both the value of the function and the limit, and it's not equal. So we have a different value for the limit, a different value for f at the x equal 1. While in this example, we don't have f defined at this value, which is 1, while we have the limit. So that's why he said, or this note says, has no bearing with on the existence of the limit. So that's why, guys, we have to pay attention that we can define the limit and find the limit, and we can find the value of this function at this point x. Thank you, guys. Hope you enjoyed the class.